Hi there, this is Professor Eckhouse, and I am talking about section 4.1, representing parts of a whole. In other words, we're starting fractions. Lots of sections in this part, lots of things going on. So be sure you're using the book that's online, and all those links take you right to it. All right, a fraction is written as a over b, where a and b are integers, so you cannot use a fraction and a fraction. Well, that's called a complex fraction, but we're not going to be looking at those. And you do not ever want to put a decimal in a fraction. So always integers. Okay, so A is the numerator and B is the denominator. So the numerator is on top, the denominator is on the bottom. All right, so we're going to use models to visualize fractions. So this is how we represent, right here, this is how we represent 3/4. So the 4 represents the whole thing is divided into 4 parts. Okay, and this is the part, okay, that is shaded. That's how we represent it. All right, you could do this also with a rectangle. You could divide it into 4 equalish sections, and then you could color in 3 of them. That represents 3/4. All right, so name the fraction of the shape that is shaded in each of these. So pause the video and give these a try. See if you can figure them out. Okay, so this first one, we've got how many total sections? 1, 2, 3, 4, 5, 6. So the denominator is 6. How many are shaded? That's 1, 2, 3, 4. 4 are shaded. So this is 4, 6. You can reduce it. Right now we're going to leave it like this. All right, the next one, how many parts are there? 1, 2, 3, 4, 4, 5, 6, 7, 8, 9. So there are 9 total parts, and 1, 2, 3, 4, 5, 6 of them are shaded. So that represents 6/9. All right, this purple one down here, we've got 1, 2, 3, 4, 5 total parts. How many are shaded? 1, 2, 3 are shaded. So that represents 3/5. I'm going to erase all my dots so it's not quite so messy. Okay. If you haven't tried the last one yet, go ahead and try that. All right. So we've got 1, 2, 3, 4, 5, 6, 7, 8 total parts, and 3, 1, 2, 3 right here are shaded. So that represents 3/8. All right, next one. Shade the following fractions of a circle and a rectangle. Okay, so do both. We're going to try both. So shade 1/5. It's already divided into 5 parts. So 1/5 would just be, you just shade one of them. Again, this is split into 5 parts. So 1/5 would just be shading one of them. All right, 2/3. It's divided into 3 parts, and we're going to shade 2 of them. Same with a rectangle, shade 2 of them. I'm getting messy and quick, but hopefully you got the idea there. All right, these are fraction tiles. Okay, so the idea here that this one represents 1 out of 1. Okay, so that's a whole. So I want you to think about then how many half tiles does it take to make 1? Hopefully you see that there are 2 there. This one and this one. All right, how many 1/3 tiles does it take to make 1? Well, we've got 1, 2, 3. 3 1/3 tiles make 1. Hopefully you're seeing a pattern here. All right, how many 1/4 tiles does it take to make 1? 4. How many 1/6 tiles does it take to make 1? I skipped the 5s. 6. Okay. And so on, and so on, and so on. So how many 1/n, n being any number, tiles does it take to make 1? Well, it takes n of them. All right. So property of 1. Any number except 0 divided by itself is 1. This is endlessly important. So important. So make sure you understand when you have a number over a number, it always equals 1. A divided by A or A over A equals 1. We're going to use that all the time. All right, so use fraction pieces to make whole out of 4/4 and 5/5. I'm going to have to pause the video now. Oh, maybe I don't. I don't know what is happening here. So let's do the 5/5. Okay, let's do the 4/4. All right, so use fraction pieces to make wholes out of 4/4 and 5/5. All right, so as you can see, I had broken this one apart, and if you put them together, that makes a whole. Okay, same thing with 5/5. That's how you make a whole. So that makes 1. So this right here represents 1. So does that one, 1. Okay, so make sure you understand 4/4, 5/5, 6/6, 7/7 makes 1. All right, so what if we have more fraction pieces than we need for one whole? Oh, this is just going to keep happening, I'm afraid. All right, what if we have more fraction pieces than we need for one whole? So what if we have 3 halves? What happens then? Oh, and it just popped up to show us. All right, we have 3 halves. Here's a half, right here, here's a half, and here's a half. So 2 of them come together to make a whole, and then we have a half left over. Okay, so we would have 1 and a half. All right, down here we have 8/5. We have 8/5 of the purple ones. So I put 5 of them together right here. That's our 1. And then the other part is going to be 1, 2, 3/5. 1 and 3/5. 1 and 3/5. Okay. All right, continuing on. If we've got 7/3, which was the last part of that question there, well, 3 of them make 1, another 3 of them make 1, and then we're left with, that was very messy, we're left with 2/3. Okay, so we get 2 and 2/3. All right, another way to think of it is we've got 1, 2, 3, 4, 5, 6, 7/3. I feel like I'm missing one. And I think I put an extra one on here. That one should not have been colored in. That was my mistake. I'll fix that before I teach it in class. So it really should be 2 and 1/3. I think I got a little overexcited about coloring them or something like that. So we've got, this one right here, this one right here should be colored like, I don't really have a light pink, but it should be colored a light pink. Oh, there we go, like that. It doesn't really work, but okay, moving on. So model improper fractions and mixed numbers. So this could be called 1 and 3/5 or 8/5, either one. Okay, so we've got the first one is, this is a whole right here, which is also called 5/5, right? And this over here is 3/5. So 5/5 and 3/5 could be 1 and 3/5, or it could be 8/5. So 1 and 3/5 is called a mixed number, and 8/5 is called an improper fraction. Okay, I really don't like the word improper because it makes you think it's wrong. 8/5 is actually an easier number to use to do all sorts of math with. So mixed numbers are actually not something we use very often in math. We usually use improper fractions. All right, so a mixed number consists of a whole number, A, and a fraction, B over C. Okay, so we've got A and we've got B over C, and we just plop them side by side and say A and B over C, or 1 and 3/5. Okay, so that's how we would name that. All right, so there's a definition there for improper fractions, but my internet is failing right now. So let's look at example 5, name the improper fraction. Oh, there we go. The fraction A over B is a proper fraction, and if A is greater than B, and an improper fraction, if A is less than B, and an improper fraction if A is greater than or equal to B. So I'm very distracted by my internet not working right now. All right, so the fraction A over B is proper if the top is less than the bottom, and improper if the top is greater than or equal to the bottom. Okay. All right, so name the improper fraction and then write it as a mixed number. So this is going in an opposite direction than many people would do it because I'm really wanting you to think about this one. So both of these are divided into the same number of parts. So 1, 2, 3, 4, 5, 6, 7 parts. Okay, so 7 parts for what per whole. Okay, so you don't want to look at the total parts for the two together. You want to look at the total parts for just one of them. All right, now how many shaded in places do we have? Well, we have 7 in the first one, 8, 9, 10. 10 sevenths. Okay, so that is an improper fraction. So as a mixed number, we would have 1 right here. And on the other side, 1, we would have 3 sevenths. Okay, so the one on the left is 1, the one on the right is 3 sevenths, also called 10 sevenths. Okay, so improper fraction, which again, I think is a better fraction than a mixed number. It's easier to do math with. That's a mixed fraction. Okay. All right, so draw a figure to model 11/8. So pause the video and give this a try. All right, so this is an improper fraction. So that means that you've got more than 1 here. Okay, so I want you to think about what's really happening here. So we've got 8/8, that represents 1, right? And we've got, how much is left over if we take away 8/8? Well, we've got 3/8 left over. Okay, so each one of these is going to be divided into 8 parts. Okay, not perfect, but whatever. Good enough. Don't be too worried about it as long as you get the gist. Okay, so this one is shaded in the whole thing. There's our 8/8, so there's 8/8, and what's left over? Well, 3 more 8s. So I'll do 1, 2, 3, like that. Okay, so as you can see, 11/8 is 1 and 3/8. Okay, another way to look at it is to come down here, divide this into 8s, and then do the same thing here. I divide it in half, and then in half again, and then half again. That's how I do it. All right, so we have 8/8 here, and then 3 more 8s here. Okay, so that's how we color these in. All right, why don't you try example 6? Okay, so I'm going to divide this into sixths. Okay, so this is the divisions, right? The number of parts it's divided into each one. Okay, so this one is going to be, see if I can do that. Oh, that was not good. Try again. Okay, so it's in sixth. Not perfect, but you get the gist. Yeah. All right, so 6 parts, each one. All right, so we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's what's going to be shaded in. All right, so we're going to shade this whole thing in and shade all of these in that we just counted. Okay. That's 11/6. All right, so if we want to divide this into 6, let's see, how could I do this? I'll do 3 parts, and then I'll divide them each in half. Something like that. Oh, not going to be very even, but all right, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so just like before, you should have a similar idea that 1 is left over. And hopefully, if you think about that, that would be 12/6. That's 2, right? 12/6, 12 divided by 6 is 2. All right, example 7. So this is going from a mixed number to a model. So go ahead and try that. All right, so since it's saying 1 and, I'm just going to say, okay, there's my 1. There's my 1. I'm not going to worry about dividing it up. 4/5 Oh gosh, we got to divide this into 5? Ah, I don't know if I can do that. All right, so we've got 1, 2, 3, 4, 5. Not the least bit even, and I'm not going to worry about it. So I'm going to go 1, 2, 3, 4 out of 5. Okay, so just 4 of them are shaded. All right, so again, I'm going to do the same thing down here. Oh, there's my 1. And when you're doing this by hand, it's just easier to do it like this. 1, 2, 3, 4, 5. So there's 5 sections there. I'm going to color in 4 of them. Okay? All right, so that's 1 4/5. Convert improper fractions to mixed numbers. Divide the denominator into the numerator. That's what you want to do first. So in other words, divide the top by the bottom. Identify the quotient, the remainder, and the divisor, and then the mixed number looks like this. Quotient with remainder over divisor sitting right next to it. All right, so I'm going to show you what I mean by that. So 13 over 7. So we're going to take 7 into, how many times does 7 go into 13? It goes in 1 time. What would the remainder be? Well, the remainder would be 6 over 7. Okay, so that's how you do it. You just look and see how many times it goes in. And another way to think about this is doing it with long division. So you're going to say 13 divided by 7. So how many times does 7 go into 13? It goes in 1 time. 1 times 7, and then I'm going to subtract. This is my remainder. Remainder. Okay, this is the quotient. And this is the divisor. All right, so look at this right here and look at what I did here. Okay, so the quotient goes out front. That was the 1. The remainder goes on top and the divisor goes on the bottom. Okay, so different ways to think about it. If you like to have steps, you can use those steps, or you can try to just think it through. All right, so try number 10. All right, so I'll do it the long way. We're going to say 37 divided by 9. How many times does 9 go into 37? It goes in 4 times, and you get 36 remainder. The remainder is 1. So 4 is our big number, right? We have 1 left over that goes on top out of 9 that goes on the bottom. All right, so another way to do it is just think through it. How many times does 9 go into 37? Whole times, 4 times. So you want to write that down. Well, then what's left over? 4 times 9 is 36. And we need to get to 37, and that's where the 1 comes from. All right. So converting mixed numbers to improper fractions. You're going to multiply the whole number by the denominator and then add that to the numerator. Okay, so I'm going to rewrite this because I want to be able to write it a little bit bigger here. All right, so you're going to take 3 times 7 and then take that number and add it to 5. Okay, so 3 times 7 is 21 plus 5, and that's going to go over the 7 still. So this becomes 26 over 7, 26 sevenths. So 3 5/7 equals 26 sevenths. All right, so try that with number 12. All right, so we're going to multiply the 10 times the 4. So those get multiplied, and then we're going to add it to the 3. So 10 times 4 is 40 plus 3, all over 4. So the denominator stays the same. So we get 43 fourths. So 10 3/4 is 43 fourths. Okay. Modeling equivalent fractions. So equivalent fractions are things that are equal to each other. They're the same thing, just with different denominators. So we've got to change the numerator too. But here I want to show you a picture of this. So if this is a whole, one whole, we are representing 1/2. So here's 1/2, and here it is right here. Okay, so 1/2 is the same, and I've got it shaded dark. 1/2 is the same as 2/4, 2/4, which is the same as 3 sixths, which is the same as 4/8. Hopefully you're getting the idea here. Those are all the same. Okay. So what have we done to each of these to get the next one? And I want you to notice, what did I do to 1/2 to get 2/4? And then what did I do to 1/2 to get 3/6? And then what did I do to 1/2 to get 4/8? Top and bottom. And the answer is, if A, B, and C are numbers, where B is not and C are not 0, then you can do this thing here. If I've got A over B, I can multiply top and bottom by the same number and I get a new equivalent fraction. Okay, so let's try that with 3/4. Find 3 fractions that are equivalent to 3/4. Okay, so we've got 3/4, and we're going to take it times 2 over 2. So 1 over 1 would do nothing. It would still be 3/4. So we're going to take it times the next number, 2 over 2. So now multiplying fractions, you just multiply across top and bottom. Okay, so I'm going to multiply 3 times 2. So I get 3 times 2 over 4 times 2, right? You don't have to write all that out, but at first I think we're going to do that. And we get 6/8. So 6/8 is equivalent to 3/4. Right, so now let's take 3/4. It wants 3 of them, so we're going to do the next number. And you can choose any number you want. I just start with the smallest ones, because my numbers are easier. So I've got 3 times 3 over 4 times 3. And I get 9/12. All right, so now we've got 3/4 is the same thing as 6/8 is the same thing as 3/12. And now let's do 3/4 times 4 over 4. Okay, and I get 3 times 4 on top and 4 times 4 on the bottom. So I've got 12/16. All right, so what this means is 3/4 is equivalent to 6/8, is equivalent to 9/12, is equivalent to 12/16. All of these numbers are equivalent to each other. Okay, so usually we spend time going the other direction, reducing, but we haven't gotten there yet. So these are just equivalent fractions, and you do it by multiplying to make the numbers bigger, top and bottom. And remember that 2 over 2 just equals 1. 3 over 3 just equals 1. 4 over 4 just equals 1. So we haven't changed the value of this. They're all still 3/4. Okay? All right, so find a fraction with a denominator of 32 that is equivalent to 3/4. So this is a little bit different kind of problem. So what they're asking us to do is to say 3/4 times what over what, and I'm going to use red here, times what over what, gives us a new fraction with a denominator of 32. That's what it's asking us. Find a fraction with a denominator that is equivalent to, that's what the equal sign means, 3/4. Okay, so here's how I want you to set it up. 3/4 times blank equals 30, something over 32. All right, so 3/4 times what? What goes right here? What times 4 equals 32? And hopefully you thought to yourself, 8. 4 times 8 equals 32. So in order to keep this equivalent, that is the key here, I need to do 8 over 8. Because remember, 8 over 8 just equals 1. All right, so I'm going to get rid of some of this, but remember that 8 over 8 equals 1. Okay, so now we've got 4 times 8 equals 32. So look at the top, 3 times 8. 3 times 8 equals 24. All right, so our fraction with a denominator of 32 that is equivalent to 3/4 is 24 over 32. So it is equivalent to 12 over 16, and it's equivalent to 9/12, and it's equivalent to 6/8. They're all equivalent to 3/4. Okay. The last thing we're going to do is locate and label fractions on the number line. This is challenging, so this might be something you want to pause and maybe spend a little time on. If you're nearing the end of your patience, you might want to stop the video and come back to it, but be sure and come back to it. All right, so we want to label 3/4 on the number line. Okay, so these number lines are blank, and the point of that is for you to figure out how to label it yourself. So if I want 3/4, then I've got enough space here. I can call this 1/4, 2/4, 3/4, and this is 4/4, so that's just 1, right? So where's 3/4 on this? That would be right here. All right, the next one is thirds. So how are you going to number this one? So I'm going to start with 0 because I don't have a negative number that I have to deal with. And I'll call this one 1/3, 2/3, 3/3. Oh, 3/3 is just 1, right? 4/3, 5/3. I think I've gotten as far as I need because my number is 4/3. So that's right there. All right, 7/3. I'm going to do the same thing. I'm just going to go 1/3, 2/3, 3/3 is 1, 4/3, 5/3, 6/3 is 2, 7/3. Okay, and that's where I need to be. So there it is, 7/3. Nope, and I should probably call this 0. All right, 2 2/5. All right, I'm not going to name every single one, but what I'm going to do is I'm going to count over. So I'm going to go 1/5, 2/5, 3/5, 4/5, 5/5. There's 1. 1/5, 2/5, 3/5, 4/5. There's 2. Okay, so I'm dividing into fifths. All right, so you don't have to label every single one. So where is 2 1/5? Okay, let me back up. If this is divided into 5, then you want to divide every whole number into 5. That's what I just did. All right, so where is 2 2/5? So pause the video for a second and think about where it is. All right, 2 2/5 is right there. 2 2/5. All right, next one, 5/2. All right, if we call this 0, this is 1/2. 2/2. Oh, 2/2 is 1, right? 3/2, 4/2, which is 2. 5/2, 6/2, which is 3. 7/2, 8/2, which is 4. So 5/2 is basically 2.5 right there. All right, negative 1/4. That means we're going to have to put a 0 here somewhere. So I'm just going to put it in the middle, 0. Now, if we call each one of these 1/4, 1/4, 2/4, 3/4, and so on, then this is negative 1/4, negative 2/4, and so on. Then this negative 1/4 would be right here. All right, 1 2/3. We've got two numbers actually we're going to put on this number line right here. 1 2/3 and negative 1 2/3. So let's put 0 in the middle. And let's see if it'll work to make each line at a third. So this will be 1/3, 2/3, 3/3 is 1, 3/3, 4/3, 5/3. Except this didn't use those kind of numbers. So I'm going to back up and I'm going to call this 1 1/3. Oh, didn't mean to do that. I'm going to call this 1 1/3, 1 2/3, and then 2. See how I thought that through? I was doing 5/3, 6/3, 7/3, that kind of thing, but this is not improper fractions. These are mixed numbers. Okay, so I've got negative 1/3, negative 2/3, and you don't really even have to. You don't even have to. Sleep is on. You can tell I'm tired. You don't have to put every single number if you don't want to. So as long as you know that each of these is a third, you don't even have to put the numbers in between. So I just erase them. So I'm just going to count over. Negative 1/3, negative 2/3, there's negative 1. Negative 1 1/3, negative 1 2/3, there's negative 2. Okay, so we're going to go find the numbers. All right, so here's 1, 1 1/3, 1 2/3, 1 2/3. Same thing in the other direction. We've got negative 1, negative 1 1/3, negative 1 2/3, negative 1 2/3. So this is really important to be able to do this easily. So please practice so that the next things we do will be easier. All right, 5/2 and negative 5/2. All right, so this is 0. So this one is an improper fraction. Okay, so we're going to go 1/2, 2/2, that's 1, 3/2, 4/2. Oh, where did I get 5? 4/2, that's 2, 5/2. So that's 2.5. Right, we can do the same thing in the other direction. but I'm going to just count 1/2, 2 halves, 3 halves, 4 halves, 5 halves. Okay, I'm not going to even put numbers. 1/2, 2 halves, 3 halves, 4 halves, 5 halves. So 5 halves in the negative direction is right here, -5 halves. All right, and +5 halves is right there. All right, order fractions and mixed numbers. So remember, A is less than B. We say this less than is to the left. If it's greater than, it's to the right on the number line. So you've got to be very careful with these and think them through. So pause the video and really think these through and see if you can figure them out and get them right. All right, so -2/3 would be here, where -1 would be farther to the left. So -2/3 is greater than -1. It's not as far to the left. -3 halves is farther to the left, so it is smaller. -3 halves is less than -3. Right, -3/7 and +3/8. Well, a negative number is definitely smaller than a positive number. All right, so -2, and then we're comparing that to -16/9. So this one's a little tricky. So we've got -2 here. Where does -16/9 fall? Well, 2 is the same thing as -18/9, right? So 2, 18/9 means the same thing, but they're negative. So where would 16/9 fall? 16/9 would fall like right here, because it's not quite -18/9. Not quite. So which one is smaller? Which one's farther to the left? So -2 is farther to the left. Those are tricky. All right, I believe, yep, this is the end of this video. Thanks for watching.